5 square, Jim. Go ahead.
Okay, I'm looking out of Fred's window. I see a lot of particles out there, but a lot of stuff is still drifting away from us. A lot of it is flashing in the local vicinity, and I don't recognize any constellations right now in this particular attitude.
Okay, Jim, if that status changes, please let us know.
That's where I continue to drift. Your 2 TCCAs are up.
And Aquarius Houston, I've got some circuit breakers you can open to power down displays. In addition, I have a P30 maneuver pad. Over.
Right, stand by. Get the pad book. Get the limb book. And say, we're getting the pad book now, Jack, and say the first power down.
Okay, I have some circuit breakers that you can open up in order to power down displays.
Okay, stand by, 1 Jack. I'm going to get my comm carrier on this. All right, I'll tell you what, get all the limb stuff. Give me the limb stuff right now. Jack, give me all the limb stuff. Fine. All right, Jack. Hey, what do you need out of here? Here. Now, is there any way I can control this thing with the limb on? Fredo? What's that? Looks like I'm cross-coupling here. I might as well... Yeah, you are. Well, I want to get out of this roll. What if I go to, well, I'm not doing any good here. Okay, how do you read now, Jack? Omni? Yeah, we're on. All right, Houston, Aquarius. Back on, yep.
Aquarius Houston, you're watching your middle gimbal there. Go ahead, Aquarius.
Okay, go ahead with the breakers first, Jack.
Okay, you watching your middle gimbal there?
It'll tell me arm. You have to just straight pitch down, Jim. Okay, you're moving away.
Okay, Fred, I've got 6 circuit breakers for you.
Okay, go ahead.
Okay, they're all on panel 11. Row 1 under AC bus B, open helium PQGS propellant display.
It's open.
On row 2, flight displays, open thrust, open mission timer, open range rate, altitude rate, and open the AC bus A, range rate, altitude rate. Okay on row 4 pings, signal strength display.
It's open.
It's open.
Okay, that's concludes the power down of displays, and I have a P30 pad for you.
Okay, go ahead.
Okay. The purpose is a paracynthian plus 2 hours dips aboard. Noun 33. 079er 25 2648 plus 16330 minus 00145 minus 07515. Apogee not applicable. Perigee is plus 00205 179er 77 835 268 264 plus 16410 minus 00145 minus 07338. COAS is NA. And I have 2 gimbal trim angles for you, which will be updated. Right now, however, we want you to go with pitch 5.86, roll 6.75. Over.
What was that for?
Pitch and yaw, maybe, huh?
Okay, what was the last 2 things? You gave me a pitch and roll angle for what?
That's for your dips trim.
Those are gimbal angles for pitch and yaw.
All right, Roger. GDAs.
Yeah, that's what I mean, sorry.
Dips paracynthian plus 2 at... Okay, dips paracynthian plus 2 at 079er 25 02648 plus 16330 minus 00145 minus 07515. HA and flash A. HP plus 00205 179er 77 835 268 264 plus 16410 minus 00145 minus 07338.
Did we lose the water in the...
In flash A on the COAS. And you gave me GDA angles of pitch 586, roll 675.
Good readback, Fred.
Yeah, get all the bags you can with water.
Aquarius Houston, say again, please.
Okay, we didn't answer back there, Jack. Check to see if you're on box.
Nope.
Neither am I, okay. Why the hell are we maneuvering at all now? Are we still bending?
Well, we're at hole for one thing. I mean, we're at the bit of impulse.
No, I mean, why can't you null them out somewhere?
Every time I try to, I can't take that doggone roll out. I gotta wait till I get around to the belly band.
Wait a minute. Do you fight roll by using the TTCA left-right? That's what you need to play with.
Okay, we'll try that. Let me get around though. Let's roll. Let it roll all the way.
Yeah, you can't let it roll all the way.
I know. But I mean...
Okay, so it's upside down at least, huh?
Yeah.
Okay. Well, shall I ask you what the return time on that one is? Are you interested?
Let's get the first things first.
Oh, you don't want to hear. Let me figure some times down here. That's at 79, and what are we at now? About
something.
We even don't even have a computer time, do we? No. Hey, Jack? Do you still have a mission timer? You don't? Okay.
Andre, well, let's ask Houston to give us a mission timer. Computer time. All right, there you go. Uplink it to us. Yeah, hold it. Go ahead. Houston, Aquarius.
Go ahead, Aquarius.
You know, we don't have I don't think we have a computer clock going, and why don't you uplink that stuff to us?
Roger. And Fredo, I got some circuit breakers on panel 16 for you.
Okay, go ahead.
Okay, row 1 under flight displays. System engineers cross pointer open. Under RCSB, open temp press display flags and PQGS displays.
Okay, they're both open.
Okay, Fred, on row 3 under comm, open displays, and under ECS, open displays.
Okay, comm displays, ECS displays, both open.
Okay, and 2 more in row 4 under heaters, open displays, and under EPS, open displays.
Okay, heaters display, EPS display open. And I've long since had all the lights off, floods, etc.
Where are those bags? Where are those bags for weighing water in the flips?
Why?
We're going to fill up command module water. We're going to lose.
Cal, you need a QD? Yeah. No way to get it in there, I don't think. See, Jim?
I wonder if one of our water gearing chutes. Okay, let's control. What else can we fill up here?
Aquarius, Houston,
We got
we're not going to be able to uplink you at time because of the IU, and we have a frequency problem there, but what I'd like to do is give you a time to set up on your mission timer and give you a mark, and then you can put it into the disky from there. Over.
Okay, stand by.
Wait a minute, why do we need a mission timer right now anyway? I mean, that bad, they tell us.
Well, I'd rather have a timer going so that then we're going to put in the disky. Then we shut down the mission timer.
Oh, is that what he wants to do?
Yeah. Hey, Omni.
Great.
Switch them. Okay, let's fire the mission timer.
Aquarius, we need forward Omni.
Forward Omni.
Say again, Jack.
Forward Omni.
I am. Okay, Houston, if that call is an Omni switch, I'm in forward now.
Okay, Fredo, how do I get the mission timer up? I got the mission timer cranked in.
You got it on?
I got the mission timer circuit breaker in.
Okay, we're going to probably need numerics lighting. There you go. You got it.
Aquarius, Houston, I think we got a better way of getting your mission time up.
The window.
Go ahead with it.
Okay, we can do a verb 55 enter, and then put an R1. Minus 00088. R2 minus 00059er. R3 minus 03274.
What's the prep and attitude?
We're okay.
God damn, I wish we'd get to something I know.
Well, as soon as we get over here, we'll stop it with the TTCAs.
Okay.
And Aquarius Houston, we've got you both on Vox.
Like to go what?
You want us on Vox, Jack?
We have you on Vox. We're reading you loud and clear, and the clock took good.
Okay, looks like we're on the SPA route there, Jack. Okay, Jack, how do you read me on normal voice now?
Hearing you 5 square, Fred.
Okay.
And Aquarius, we're ready for verb 74 when you can give it to us.
You got it.
Okay, and one other thing we noticed when you pressurize the RCS, we got an increase in pressure in the ascent tanks, and so we'd want to have you verify that the ascent feeds are closed. In order to do that, on panel 11, close ascent feed 1 and 2 circuit breakers. And cycle the Parker valves, and then open the ascent feed circuit breakers on panel 11.
Completed, Houston.
Okay, Jim, thank you.
And Jack, Aquarius, what kind of return time does this maneuver give us?
That puts you back in the water at 133 hours.
133, eh?
Affirmed. And that's an Atlantic landing site.
Atlantic landing?
Affirmative. That's the pad that we've given you, but we may change our mind later on. We want you to have this info for now. And that's a minimum time return.
Should start out by saying that we have a serious problem in the command and service module. We appear to have had some kind of accident with the in the region of the fuel cells and the oxygen tanks. We have not tried too much to reconstruct the what has happened because we were more concerned at the moment for getting the situation under control. As you have seen, we've begun to use the LEM as a device for keeping oxygen in both the command and service command module and the lunar module, and we're using the power system from the lunar module. It appears at the present time that everything is under control and that we have a safe situation at the moment. I think Colonel McDivitt may want to give you some more details on the systems, and Mr. Sjoberg could certainly talk about the operations plans that are going on at the present time in the control center.
Right, Chris. The way we have the spacecraft configured right now is with the CSM powered down completely. Before we powered it down, we were able to isolate the surge tank and the emergency repress tanks in the command module. These provide oxygen for reentry, so we have a command module that has oxygen for reentry. It has the reentry batteries, it has pyro batteries, and all the systems that are in the command module. Our malfunction apparently occurred in the bay, which includes the hydrogen tanks, the oxygen tanks, and the fuel cells, and was in no way connected with anything with the command module. We should be able to provide power, electrical power, from the LEM for the return voyage to Earth. We should be able to return on the oxygen within the LEM, and we will be using the lithium hydroxide out of both the command module and the lunar module. We can still power the command module from the lunar module at low power levels through the wiring which is normally used to power the LEM from the command module. So we expect that we'll be using a dual spacecraft mode from now until the time that we get back to Earth. We'll be firing the LEM engine at some time later to accelerate our return voyage, and I think Sig probably comment on that best.
Yeah, the minimum return to Earth time, this would be a total flight duration, would be about 133 hours. That would result in a landing in the Atlantic. That's one option we have. A second option would be to go to the Pacific line. That would take about 142 hours total flight duration. The burns to get you back would be made at about between 77 hours and 79 hours of flight from liftoff. We'd anticipate that the decent propulsion system would be used for maneuvers, and it has the capability of either of the ones I described.
We're ready for questions now. Please wait for the mic. We're going to have to get all this where are we? Are you ready? Let's start here and work across. Mark Bloom, then we'll go this way and we'll turn over to the aisle.
For Jim McDivitt or anyone who wants to ask, how much electrical lifetime do we have in the LEM, and how much oxygen lifetime? How long do we have?
Well, Mark, it depends upon how we use it, obviously. We have 4 batteries in the descent stage of the LEM with 400 amp hours each. We have 2 batteries in the ascent stage with 296 amp hours each. If you rough that out quickly, it says we can use power at about 25 amps steady current until we get back. Now, we'll have to arrange the electrical profile so that we can bring up the systems to perform the dock DPS maneuver, and then we'll power down to minimum levels and go along like that. When I left, we had an ample power supply to do the whole mission, but we were still roughing it out and trying to get in a configuration which we knew. Oxygen, we have 48 pounds of oxygen in the LEM descent tanks, which is more than adequate to do the mission. We also have a couple pounds in the LEM ascent tanks. I think I said descent. Descent tank has 48 pounds. The ascent tanks have about a pound or so.
Point out that we have locked up the CSM systems to preserve that spacecraft for reentry, both in terms of power and oxygen. So it is sufficient to support entry.
The command module is completely intact. There's no problem with it at all.
I wonder if we can expand a little more on the possibility of an Atlantic Ocean landing and what the recovery posture is for the Atlantic.
For an Atlantic landing, we would have airplanes with parajumpers on the scene at the time of landing. We're presently surveying that area of the Atlantic. If I remember, it's about 20 or 25 degrees south and about, I think it's about 25 or 30 degrees west longitude. And we're presently surveying the area for ships of opportunity. But we do not have a planned recovery ship in that area, as you know.
Let me follow up on that. Would you say that now it seems a great deal more likely that you'd go for 142 hours and the Pacific, where you have a recovery capability?
I think that's a good possibility, but I'd like to reserve judgment until I see what happens in the next hours. We have some 18 or 19 hours until that burn has to be made, so I think we'd certainly be watching the situation. The Pacific is a lot better from the standpoint that we have the ship there. It's better from a network standpoint, so it's a preferred place, even though it might take a little longer.
Chris or Jim, can you tell us where the 3 astronauts are and how they will be living in their return to Earth?
Well, when I left, I think that Jack Swigert was still in the command module and Jim and Fred were in the LEM. And I think that they'll be living between the 2 spacecraft until they return. Sometime before re-entry, of course, the 3 of them will return to the command module and put the hatch back in and jettison the LEM, jettison the service module.
If I were going to guess, I'd guess that 2 of them would sleep in the CSM while the other one stayed awake in the LEM. I would guess that they'll probably go to some kind of shift like that.
Yeah.
And I'll follow it up. How are they going to be getting oxygen and heat in the command module? From the LEM?
We're going to be running one environmental control system or the other. Initially, we'll be running the LEM system. That's what we're running right now. Now, intermittently, we'll run the CSM system to make sure that we keep the atmosphere in the LEM free of carbon dioxide. So we'll be alternating. That's why I say there'll be people in both spacecraft.
Let's take them over here and we'll come back on this far side. Right there, yeah.
Yeah, will somebody explain to me what you mean by a ship of opportunity in the Atlantic? Is that some merchant ship or Russian sub that happens to be?
It could be a merchant ship. It could be, I suppose it could be a foreign nation's naval vessel. Any of that kind of thing.
You mean any ship in the Atlantic?
Yes, sir. Right here.
Chris, has this abort situation or altered trajectory ever been run on simulators in just this way?
Oh yes, many times we run all kinds of abort situations, and if you recall in Colonel McDivitt's flight, we actually burned the DIPS engine attached to the command and service module. The autopilot in the lunar module is designed to carry out the maneuver under those circumstances. That is the digital autopilot to damp the oscillations of the combined spacecraft. We are looking even at the possibilities of dropping the service module, but that particular type of maneuver has not been tested in flight, and we'd have to make ourselves certain that we could control the spacecraft under that kind of CG and inertial conditions. So that's kind of unlikely that we would do that. If we did that, it would give us that much more delta V, you see, because we'd get rid of quite a bit of weight from the CSM.
Zach Strickland?
Chris or Jim, if you've got a situation where the LEM oxygen system can provide like 50-plus hours for 2 guys, how do you equate that with 146 hours return if you don't have any kind of environmental control operation in the command module right now?
Normally, on the lunar surface, we plan on 3 lunar surface repressurizations, and it actually has enough for 4. Now, there's about 6.6 pounds of oxygen per repressurization required, and the LEM leak rate is about 0.08 pounds per hour. The metabolic rate is a little bit, and we're using probably 0.2 of a pound per hour, so we've got quite a large margin there.
You recharge the plisses also.
Pardon?
Let's get this straight if we can. You're saying you use 0.2 of a pound per man per hour?
A better number is 6 to 8 pounds for the 3 men per day.
6 to 8 pounds per hour.
Correct, and that plus what you might have for
yeah, you have to
leakage.
take in the cabin leakage too.
All right.
If I can follow up here just a second. Have you got enough oxygen to get them back safely?
Yes.
All right, over here.
According to the press handouts, the Navy's got a standby task force in the Atlantic to recover if necessary. You wouldn't go to this, you'd go to the ship of opportunity, emergent ship if necessary?
We don't have a U.S. Navy recovery ship in the Atlantic.
Is deemed necessary for this mission?
It was not deemed necessary for this mission.
Sig, where was the Atlantic recovery point again, geographically, if you could, and the Pacific?
This is rough, Paul, but it's something like 20 to 25 degrees south latitude, and I think it's about 30 degrees west longitude.
Just below the point of South America there, Paul.
The bulge in that area.
Due south of that.
You mentioned that you should be able to generate around 25 amps per hour, and you have to divide that out against the loads. Will there be sufficient power for the transponders so that you can get a good track on the spacecraft?
I will be able to bring them up when we need to, and I believe that we'll have that kind of power. I really don't have that close a handle on the power. We came over here before we had all those details worked out to that level.
As long as with the Omnis and the 220-foot dishes, I don't think we'll have any problem.
Also, I appreciate that you haven't been able to give any thought to what caused all this, but there I was looking through the transcript, and there were certain problems with the O2 tanks, and cryo temperatures, and problems with fan cycling and stratification. Because this, apparently one of the tanks was oscillating very rapidly in temperature, and this was noted earlier today. Does this give you any thought of what might have happened?
No, not yet. Stratification is something that typically happens in these tanks, and it's nothing that we haven't seen before. Right now, I have absolutely no clue to what happened. We had something...
It was pretty widespread, we know.
Rather violent happened in Bay 4, we think. Something happened to the fuel cells in the oxygen tank, and they were down in that area. It was a rather violent kind of thing because it apparently reset some of the check valves in the RCS quads, which are susceptible to shock. But as far as what exactly happened, I have no idea.
Chris, are you confident that you have enough power under the current configuration to bring the follow back in?
Yes, but I think we'll have to be very frugal in how we use it, and that's what you probably heard some of the discussions back and forth between the crew. We were trying to consider whether we would keep the platform up, for instance, between now and the time you go behind the moon, in order to maintain that alignment so that they wouldn't have to do another alignment when they get ready to do the burn on the dips and so on. So it will have to be very carefully used between here and Splash.
And how do you feel in point of concern between now and Gemini 8?
Well, I guess I would have to say I feel a great deal more concerned. We're still something like 70 to 80 hours away from the Earth. And in Gemini 8, we were never more than an hour and a half to get to a recovery point and never more than 20 minutes to land.
Carl, we'll come back in and move up this way. At the time that you left, what was the situation with regard to venting to the outside and motions of the spacecraft from that? Was there any?
I don't know.
I can't recall.
The venting had been decreasing, and if we were leaking probably from that bay, and it looked like the pressures were all dropping, so that I would assume that the venting had gone down, but it was a little difficult to tell from the conversation. I would assume that the venting had decreased considerably.
You were not getting any particular rates anymore at the time you were leaving?
Not that I recall. I think they had the LEM RCS system up, and so it would be difficult to tell even then whether they did have any rates.
They were transitioning from one spacecraft control system to another and running back and forth through the tunnel and aligning the platform. There's an awful lot of activity going on, and we didn't ask them what the rates were.
I believe I heard Fred Hayes mention that it might be considered to use a deep space abort in order to immediately get the burn over with and power down the LEM so you wouldn't have that drain in keeping it powered up till they get around the moon. Has this been completely disregarded now?
We can't, the position we are now on the Earth-Moon plane, we have to go around the moon to get back if we're going to use the DIPS engine. You would have had enough capability with the SBS engine, but of course we don't dare use that now. So we have to go to the backside of the moon and come back.
I have a question in three parts. First of all, if they do choose the Pacific method of recovery, will the recovery point be changed from original planning, or will it still be the same?
I think it's moved west and south some. I think it's about 165 degrees west and some 20 degrees south. It is farther south and farther west than the end of mission plan.
With this, the other two questions kind of combine. If you did land in the Atlantic and you did have to go to a ship of opportunity, would you hesitate at all to ask any ship of any nation?
No, sir, I wouldn't.
And will this necessitate future thinking toward a backup recovery fleet in the Atlantic?
We certainly will reassess that, yes, sir.
That would have the back.
Chris, will you come in at 400K, and will there be any problem in jettisoning the LEM entry, or what will be that mechanics?
It's done the same way as it is around the moon, and the same way coming back from the moon with the service module. You have pyrotechnic batteries and separate pyrotechnic lines electrical sources, which are dependent only on those power sources. So we don't have any problems there in terms of separation. Now, the dynamics, mechanics of the thing would not be a problem either.
For Jim McDivitt, is a situation like occurred in Bay 4 something that might have occurred if it was hit by a meteoroid? And for Chris Kraft, in following up your earlier comments, do you feel they have a good chance to make it back?
Well, you asked me first. There was something which appeared to be quite violent that occurred in Bay 4, and yes, if you were struck by a meteor, it would be quite violent. I'm not assuming that's what happened, Mark, but that could have done it.
Yes, I think their chances are excellent at the moment, assuming that the lunar module continues to operate well.
Can you think of anything else that might cause such a violent event besides a meteor?
Well, we could probably think of an infinite number of things that could...
Well, 2 or 3 that would be within the realms of likelihood, I mean.
I guess I really... There are a lot of things that could have happened. It would be just pure conjecture. Anything that's down there that's pressurized could have let go, and there are all kinds of pressurized things. There are pressurized hydrogen, nitrogen, oxygen, fuel cells. It's a very complicated bay that this happened in.
What is the moment that you have to get everybody out of the limb and back into the command module and seal it off and get ready for entry? I mean, how late can you continue to use the limb before you have to go to the batteries on the command module?
It's pretty late. It doesn't take too long to get back in the CSM. The thing that you want to make sure is that you have adequate time to put the hatch in and blow the limb off, and that really doesn't take very long.
I'm sure that will be a process where a couple of them will get back in the CSM, get everything set up, and they'll do that as late as possible.
How late? I guess we'd have to work that out. 30 minutes or hour or 15 minutes or some range like that.
We want to start using the CSM batteries as late as possible.
Okay, we're going to come up the middle. Harry?
On the present trajectory, how far beyond the moon will they go before they start to hook back? And what would the miss distance at the Earth be without a correcting burn from the dips?
Well, on the present trajectory, we would come within about 60 nautical miles of the backside of the moon. We are not on a free return trajectory at present. It would take a very small burn, say in the next 5 or 10 hours, to get us back on a free return in the order of 20 to 40 feet per second. I can't answer your second question about how far we miss. I don't know.
Right here.
Will the dips burn be the major rocket maneuver you will make on coming back, and if so, where will it be? On the far side of the moon? Or
It'll be on the far. Yes, it will be the dips. It will be on the some place between Paraloon on the far side of the moon and 2 hours after that.
Let's pick these up coming up the middle of the aisle. We'll just take them both sides again. All right, follow. Do you recall the approximate mileage at which points you could still do a deep space abort and come back? What is the crossover? 140, 150,000?
It's probably farther than that, Paul. I don't remember the exact number, but I think at the time of this incident, if you'd used the SPS engine, you could just about have done it, but it would have taken just about the whole thing.
176,000.
Something like that.
If I recall, Paul, I think the number was 9,000 foot per second and about 140 hours.
What would cause you to choose the Atlantic over the Pacific for recovery? And are you now surveying the Atlantic to find out what ships are available to you?
Yes, we are surveying the Atlantic to find out what ships are available. I think the only reason you go to the Atlantic, if sometime between now and the burn, something would happen to make you very time critical in getting back.
Burn more quickly or sooner?
No, it's a bigger burn to go to the Atlantic. It's about 2,000 or 1,900 feet per second and gets you back some 9 hours earlier.
How many people were in
It's about 900.
Let's come up to, we have the gentleman in the middle of the row there, in the khaki jacket.
In the transcript, I'd like to read from this. Lovell says, yes, I've got to put the cabin refit valve in there. Every time he does that, our hearts jump in our mouths. Now, I don't understand what he's talking about here, but could this have anything to do with the accident? If something happened that made their hearts jump in their mouths, what was it?
I think he's talking about the cabin repress valve in the limb, which goes bang when you operate it.
Well, McDivitt said that any pressurization could do anything. Is there any link here?
Any pressure? No. I guess I don't understand the question.
What you're asking is, did that statement have anything to do with the accident? And I think definitely not. So he was talking about something that went on in the lunar module as opposed to where the accident occurred in the command service module.
I'd like to go back to Bay 4. Do you expect to be able to tell exactly what happened there, and if so, how soon?
Well, we have people working at it right now, and I don't know whether we'll ever be able to tell exactly what happened there or not. We're reducing the data like we do on all of the space flights and whenever we have an anomaly, and to date we've been quite successful in determining what happened. Whether or not we are in this case, I have no idea. We're certainly going to do the best job that we can. Well, sometimes it takes a long time. I have no idea on this. I haven't seen the data myself at all. We were trying to figure out what to do rather than to play out the old data.
And that's what we'll be doing till we get them back on the water, is concentrating on everything that is their lives are dependent upon at the moment rather than worrying about the accident, because there's nothing we can do about that now. This service module is no longer useful in most cases because the oxygen is depleted. So other than the fact that you've got some propulsion left and the batteries in the command module, and we're going to worry about those situations from now to splash.
Initially, we were trying to find out what was wrong down there so we could possibly correct it before we lost the oxygen. We weren't able to do that in time, and I think that we'll put that effort on a very low priority right now and work on the other stuff. Pardon? No hints.
What about your thermal control situation? Do you expect any problems from heat because of your configuration now?
Well, we're not going to be able to just maintain a single attitude hold all the way to the moon and back. We're going to do something, and we've been working on that. I guess the guys are working on that now, aren't they?
I don't think we can answer that question truthfully, because we've never had a situation where we've not had powered up conditions in the command module and powered conditions in the LEM. So that's probably going to be a real-time situation.
Chris, at the risk of asking you to oversimplify a very complex situation, and certainly I don't mean this facetiously, is there any real concern, can you get them back, taking into consideration all the imponderables, the power, the oxygen, the landing area, and all this sort of thing?
If the situation remains stable as it is at the moment, there's no question but what we have the thing under control and we can return the crew safely to the Earth. Now, we're going to have to make some compromises in procedures as how you do that, but that can be done. We've got a number of different ways of doing things, like re-entry. If we couldn't, for instance, get the platform up, we have what we call the entry monitoring system. We can enter at constant G if we had to with no entry monitoring system. If everything remains as is, we can get them back successful. Now, if there was some change in the status of the lunar module, then that might mean something else, and we will keep you appraised of that situation.
All right here.
What can you anticipate that might happen that already hasn't happened? Can you give us an indication of what could happen?
You might have some problem with some system in the lunar module that would put us in a very serious situation, like a leak in the oxygen system or something that would happen to the electrical power.
There's no indication now that there's anything wrong with the LEM. It's performing properly, and like Chris said, if everything works the way it is now, there's no doubt that they'll come back all right.
Okay.
What time did the accident occur?
I don't have an exact.
Yes,
it must have been 56 hours.
Yeah, 55 and a half to 56 hours in that time period.
All right.
The crew being wearing their space suits, or will they be shirt sleeve, or how will they be traveling the rest of the trip?
Well, they're shirt sleeves right now. I would guess they'd probably stay shirt sleeves. I see no reason to go back to the suits.
Yes.
Yes.
All right, we're going to take these two here, and we're going to come back on this side.
Jim, I'm not clear on what the vetting did to the spacecraft's attitude and pitch roll in yaw.
Well, he had a negative pitch and a negative roll, and that's one of the clues that we had that something happened in Bay 4, in addition to the fact that we had all these other anomalies to the equipment that's in there. It meant that it was pitching nose down and it was rolling to the left.
I think the other thing you have to remember is that we have certain instrumentation that we can believe or not believe. I mean by that when you have something like this happen, you don't know that you're not reading false information from some of the instruments. So you have to look at those and see how they failed, etc., and see what the measurements are, and see which direction they went when they began to fail, to see whether that you're reading true information.
All right, this one, and then we're going to come back on. Chris, could you put this in a somewhat larger perspective? It seems obviously that if this happened on the way back, the situation would be critical. I mean, it would be fatal.
Indeed it would.
You discuss this thing from the standpoint of the resources you're left with when it fails at this point in the mission.
Well, any time that you still have the lunar module in the condition that we have it in this case, where we've not used any of its consumables, then we're in a very good situation. We've always called the LEM a good lifeboat under those circumstances. If at any time in the mission, however, the LEM had separated and we had gotten ourselves into a rendezvous situation, or the command module being around the moon, then what you state is absolutely true. It would be a fatal situation.
What is the critical consumable? Water, lithium hydroxide, oxygen, electrical power, or what? And how long will it last?
Well, as I mentioned earlier, it varies on how you use them. If you turn everything off, then electrical power is not a problem, but of course we have to use it. Oxygen we have more than the sufficient quantity, and the LEM is self-sufficient except for the lithium hydroxide. We're going to have to be using lithium hydroxide out of the CSM to maintain the CO2 level at a lower level. So from that standpoint, we have to use both the command module and the LEM. From an electrical standpoint and an oxygen standpoint, we can use the LEM alone.
Enough water?
Yes.
When the fuel cells aren't functioning?
Yes, the LEM has a large amount of water that it carries. The LEM cooling is done by water. It uses a sublimator rather than radiators, so we'd be using that water for cooling, and there is enough.
The individual life support system packs that were meant for the moonwalk, can they be used inside of the spaceship?
Yes.
Thank you. All right, we're in the very back room.
How do you thought given to cutting down communications to conserve electrical power, to setting a timeline of we'll talk to you, thus and so at such hour?
I don't think it makes that much difference.
At this time, I don't think we have to do that.
Right.
Initially, we wanted to get the spacecraft configuration under control so we knew where we were. And as I said, we've got to average about 25 amps or something on that order, plus or minus a few amps. And it's better to burn a few extra amps right now, figure out what you're going to do, and have all the capability of taking things out later. But you want to make sure that you've got a condition you can live with now.
I might say that if we're in a condition where we don't have the 220-foot dish, communications may be somewhat sporadic without the high-gain antenna, which we would probably not want to bring up because of power reasons in the LEM.
I know it's probably a little premature, but seeing they have had a rough time, have you worked out any schedules for a sleep period for any of the astronauts?
No, I think this is a little premature for that.
Mary?
Chris, if the LEM continues to operate well, what is your, on the systems and the power and all that kind of jazz, what is your primary concern? Do you have any concern about the spacecraft, things working sufficiently in it to bring it back?
No. I think that with the ground situation that we have, that is the tracking we have from the ground, the maneuvers that we can give them from the ground, I think that we're perfectly satisfied that that situation is well under control.
Would extreme weather conditions affect your choice of landing sites, and do you have any idea what the weather will be like in the landing sites?
I haven't looked at the weather yet, but we would still have range control during reentry, some hundreds of miles, perhaps 1,000.
What will the procedures be for the rest of the night?
They are not defined yet.
All right. Chris, you were in a catbird seat on John Glenn in a retro pack that didn't come off, Scott Carpenter in an overshoe, Dave Scott in a stuck thruster. How would you, and forgive me if I put you on the spot, but how would you classify this situation as regards to these that we are familiar with a little bit?
I'd say this is as serious a situation as we have ever had in manned space flight.
Jim, two questions. One, with the situation of using the lithium hydroxide in the lunar module, will there be any chance the air might get stuffy at all before this is out? And could you paint a picture for us of what it's like in the command module with it powered down? What does Swigert, whoever's in there, see? Is it just the lights from the computer, or the disk keep blinking, or what?
Well, we'll first let me answer the one about the lithium hydroxide. We'll be using the lithium hydroxide out of the LEM, and then we'll be using some out of the command module, then some out of the LEM, then some out of the command module, trying to keep the environments in both spacecraft acceptable. The disk key has been turned off. The command module is powered down now, so there won't be any lights in it at all. We'll be using this flashlight. We have 3 re-entry batteries in the command module, and we have no way of recharging these things now with the fuel cells gone, so we don't want to waste any of this valuable electrical power by running unnecessary equipment in the command module. Now we do have the capability of powering some things in the command module from the LEM as long as we keep this power load down low via the umbilical that runs through the tunnel.
In a report a few moments ago from the Aquarius, they were still having problems with their roll, and they had not attained the configuration that they wanted. My question is, do you know precisely where they are? And are their computers operable and in tune with yours? You talked about perhaps some of the instruments giving you bad readings. Do you know at this moment precisely where they are?
Oh, yes, I think we know the trajectory they're on, if that is your question. Yes, sir.
We may not know exactly what their alignment is. I think that we were fairly well satisfied that the CSM and the LEM were properly aligned with each other before we shut down the CSM.
Hole that was caused by this?
I don't think we know that.
As far as we know where the LEM is, but it doesn't know where it is, because when we went in there and powered it up, we only went through that part of the power-up procedure that brought the IMU on the line in a known configuration. All that equipment, all that erasable memory that has to do with where it is, isn't in there, and the LEM really doesn't navigate normally between the Earth and the Moon anyway, so we're going to have to keep track of it from the ground. And the main thing is the LEM provides the attitude with respect to the stars, and that's the reference which we'll use for all powered maneuvers.
Well, these men are very anxious to get back to work, so we're going to take about 2 or 3 more questions and then cut it off. So
Chris, I know this is very early to answer this kind of question, but Project Apollo had a pretty carefully thought out lineup of things that you wanted to do. You curtailed it by eliminating flight number 20. Now, for practical purposes, you've eliminated flight number 13 as far as lunar exploration is concerned. Can you give us any idea at all what this breakdown is going to do to the rest of the program?
Well, I'm sure that we will reassess the landing sites that have been chosen. We'll reassess the command service module itself. We want to satisfy ourselves that we've done the best we can before we launch again. I believe that in terms of the landing sites, we will probably reconvene and go through our landing site selection again to make sure we're satisfied that that is true. I think we've done that enough now, however, that we can probably come pretty close to laying out the sites that we'd like to go to.
Would you think that the 6-month hiatus between shots that you've laid out for yourself now would be sufficient to get a handle on what was wrong with the service module and correct it? Or do you think that there might be a delay, a stretch out as a result of that?
Well, I think that's very difficult to answer, Bill. Let me say this. I don't think we would hesitate to wait a longer period of time than 6 months if we were not satisfied.
The dips bearing that has been referred to, would that have to occur behind the moon out of radio contact, or could you fix it so that you could perform it in radio contact?
It could be in radio contact, possibly.
Here. On the backup systems, the way the various backup systems, as far as moving into the limb, and the various systems that have backed themselves up, the emergency systems, are you satisfied with the way they've worked? And is this giving you an insight into things that might be needed in future flights, even more backup systems that would back up some of these possibly that have now failed?
Well, the command and service module was designed to be an independent spacecraft, and we built the redundancy into the spacecraft. This was, whatever happened today was one of those cases that's very difficult to design for. We had something happen which was a major consequence down in that bay, I think, because of the multitude of things that occurred when you lose 2 fuel cells and an oxygen tank, and the oxygen runs out of the other, and all that. That's something very significant. It'd be very difficult to design against that. We were fortunate that we're on the way to the moon with the LEM on board, or LEM attached.
So I wanted to ask about, you say that on the return flight this could have been extremely critical. Are you thinking now in terms of something to do in the event this should occur on a return flight?
I think that would be pretty near impossible to do at this time with that vehicle.
One's here, and then we're going to take Mary, then we're going to have to close it up.
Did the fact that you went into a hybrid trajectory yesterday, pulling you out of free return, is that going to cause you any troubles in trying to get back around the moon?
No, as I said earlier, we're not on a free return right now, but it would only take a maneuver of about 20 to 40 feet per second to get you back on a free return. That could be done in, say, 5 or 10 hours from now, if we chose to do that.
Chris and Jim, do you have any feeling of how the crew feels, and also Marilyn and Mary on this situation?
I would only guess that the crew feels that the situation is under control, but that they were in a serious condition, and they knew they had a job to do, and I don't think they stopped to consider what their personal feelings were at the moment. You'll have to wait and see how they felt about it themselves. As far as the wives are concerned, I'm sure Deke Slayton has talked to them, but we have not.
I think when you're in a spot like that where you're busy and you have a lot of things to do, I think you just go ahead and do them. And the crew's been jumping back and forth between spacecraft and powering systems up and down and maneuvering around quite ably in the spacecraft, and they've had the situation well in hand. So I think they've been probably too busy to sit back and...
Certainly they have remained very calm and responsive to the discussions from the ground, and I'd say they have the situation well under control.
We're going to continue to schedule these briefings throughout the mission whenever there's a point where we think interpretation would help, and we'll be back again, but I think we ought to get back to mission control now.
Quick one. If you want.
Aquarius Houston, we've got to change the rest mat to the one to which you're aligned, so we'd like to have who and data, and we'll ship that up to you. Roger. Okay, you got it, Jack. Roger, coming up. Aquarius, could you give us data, please?
Okay, you got it. The up data link, the DUA breaker may not be in, Jack.
Okay, Fred, close the DUA breaker.
It's in, Jack.
Okay, Jim, and it's coming up now. Thank you.